Hey mathematicians, in this lesson we are going to learn how to factor quadratic trinomials when a is equal to 1. And I know that learning target probably sounded like Greek to you, so I'm going to break it down for you. And I'm going to use the video that I hope you just watched where we multiplied two binomials. So the two binomials that we multiplied together, it would help if I wrote the right letter, were x plus 2 times x plus 3. And you'll recall from the previous video that we took those two binomials. Okay, so those two binomials were had two terms each. We know we multiplied them together because there was no adding or subtracting in between there. And the final product when we got finished was x to the second power plus 5x plus 6. I'm not going to review how we got that. If you don't know, please go back and watch the other video. And so this answer that we got in the previous video, this x to the second plus 5x plus 6, matches our learning target for these reasons. Okay, I'm going to skip over the word factor for a minute, but I'm going to go to the word quadratic. So the reason that this is quadratic, and we're not going to get into formal definitions right now, but it's because that exponent in the front, that exponent is a 2. You would think the quadratic has to do with the number 4, and in this case, it does not. So the reason this is quadratic is because that lead exponent is a 2. The reason it's a trinomial is because we have 3 terms. We've got x squared, we've got 5x, and we've got 6. So we have 3 terms, which is why this is a trinomial. And I'm going to spend a little extra time for a minute talking about this idea of a is equal to 1. So the trinomial we have here, x to the second plus 5x plus 6. Mathematicians have given variables that we use to designate the numbers that are components of this trinomial. So what do I mean by that? I mean the 5, the 6, and before you tell me that there is no number here, remember that even though we don't see a number, there is technically a 1 there. And the 3 variables they use to represent this, so the number in front of the x squared, they use a. For the number in front of the x, they use b. And for this constant, they use the letter c. So the reason that this fits in with the learning target where a is equal to 1, it means that hidden number, you know, that number that we know it's there, but we just don't see it, in front of the x squared is a 1. And it is going to be important soon that the number in front, that the second number, the number in front of the x is b, and that we do use this for c. That'll be important in a minute too. But the reason that the procedure we're getting ready to learn about, we're able to do it is because, once again, this x squared plus 5x plus 6 meets these 3 conditions. First of all, it's quadratic, which again, remember, quadratic means it's got that exponent of 2. It's a trinomial, and it's a trinomial because it's got 3 terms. And finally, a is equal to 1 because that number, that coefficient in front of the x squared, the a, is a 1. So that is why what we're getting ready to do is going to work. So now let's talk about the part of the learning target that I glossed over, which is factor. Like, what is it exactly that we're getting ready to do with this quadratic trinomial where a is equal to 1? So we're going to start with the quadratic trinomial where a is equal to 1. And we're going to do the exact opposite of what we did in the previous video. Instead of ending up with this quadratic trinomial, this is where we're going to start. And at the end, we are going to get the two trinomials, or I'm sorry, the two binomials that we multiplied together in order to get that trinomial. So we're doing the opposite of multiplying. This is not a mathy term, so I'm going to put it in quotation marks. So factoring means you're like unmultiplying it. You're taking the quadratic trinomial and you're figuring out what must have been the two binomials that I multiplied together in order to get that quadratic trinomial. So we're going to do the exact opposite of what we did in the last video. So even though we already know what the two binomials were that we multiplied to get this quadratic trinomial, I'm going to still use it as a way to demonstrate the steps that you would use in order to figure out what the binomials were for any other quadratic trinomial. I think it might be helpful to use one that we've already been exposed to so you can see how the steps relate to what you already know how to do. So we are going to write a list of steps. So if you are doing notes with me, go ahead and write the learning target here at the top. So how to factor a quadratic trinomial when a equals 1. Go ahead and write that trinomial. And then we're going to do the steps over here to the side, but I'm going to explain where the steps came from as we're going through it. So step 1. Is that we're going to factor, and again, I'm going to use the term pull apart. Not very mathematical, but you kind of get the idea. We're going to pull apart, unmultiply that first term. So that first term is an x to the second power. And you'll recall from the example that we did previously when we were multiplying, I'm going to show you a visual image here. So here's the reminder here of what we did in the previous example. So we multiplied an x times an x, and we got x squared. So this time we're doing the opposite of multiplying those together. We're going to unmultiply them. We're going to pull those two x's apart so that they're going to be an x and an x. And we're going to place them inside empty parentheses. So because we've got a quadratic trinomial where a is equal to 1, we know that more than likely the way we probably got it was by multiplying two binomials together. So I'm going to go ahead and take my two empty sets of parentheses, and I'm going to factor, I'm going to pull apart that first term. So how did we get that x to the second power? We did it by multiplying an x times an x. So, and I'm going to put those inside of those empty binomials there. Now for step 2. We need to determine two numbers that you would multiply to get C. And remember that C is the third number in that trinomial. So two numbers we would multiply to get C. So in this case, that's going to be 6. That will also add to get B. And remember, B is the number in front of the X. Let me actually just underline these instead of circling them so that I'm not having you guys lose any information here. And so let me explain by using the previous example why that's going to work. So looking at when we actually went back and we multiplied these in the previous video, we multiplied those two numbers that were at the end, and that's where the number came from, right? We did 2 times 3 and we got 6. And then because we multiplied a binomial by a binomial, remember in both cases, we ended up with these two middle numbers or terms that had x's. So whether you did the box method or whether you did the distribution, you ended up with two terms that both had an x. So both of those terms, the 3x and the 2x, we added them together, right? And that's where we got the 5x from that became our final answer. So that is why we need to determine, we know that the last two numbers in those binomials need to multiply together so that we're going to get C, so that we're going to get that third number, but they also need to add in order to get that middle term, which is going to be B. So what I personally do is I always just kind of set up a table. So try to figure out what I'm going to multiply to get C. So in this term, what I'm going to multiply to get 6, that I would add to get B, which in this case is going to be 5. And I know we already know the answer to this, so we're going to pretend for a minute that we don't know the answer. So it's helpful just to kind of run through the numbers that you would have to multiply in order to get 6. So for example, 1 times 6. Can you add 1 plus 6 and get 5? Nope. So you know those aren't the two numbers that you're looking for. So the next one would be 2 times 3. Oh, look, 2 plus 3 equals 5, right? So that's how we know that those are the two numbers that are going to go into those binomials. And it has to be a positive 2 and a positive 3 because positive 2 times positive 3 is positive 6, and 2 plus 3 is 5. So that's how we know it's going to be x plus 2 and x plus 3. So once we've determined those two numbers, I kind of breezed past that, didn't I? We're just going to place them inside. They're not empty anymore, but we're going to place them inside of those binomials. So step 1, we're going to factor. We're going to pull apart that first term. Step 2, we're going to figure out what were the two numbers that we had to multiply together to get C, that we had to add together to get B, and those two numbers, once you find them, are what goes inside of those parentheses. So the final answer is just x plus 2 and x plus 3, which of course we already knew. So let's try one where we don't actually know the answer ahead of time. So this time we don't know the exact numbers that it's going to be. So we're going to need to follow the steps. I'm not going to write the steps down, but I am going to use the same color coding that I did for the steps before. So step 1, we need to factor. We need to pull apart that x to the second power, right? So we're going to pull it apart into an x times an x, and I'm going to place them inside of those empty binomials that I know, or inside those binomials that I know I'm going to end up with at the end. And so step 2, I'm going to make a table to make it a little bit easier. So what did I multiply, or what can I multiply to get C? So in this case, C is 18. So what did I multiply to get 18? the same two numbers also need to add to get B, which in this case is going to be 9. So if you're kind of struggling with number sense, I totally get that. That's why I try to do it a little systematically instead of just sitting there trying to rack your brain all day. It's a good idea to start with the multiplication side and just think in order of the numbers that multiply to get 18. So for example, 1 times 18. Does 1 and 18, if you add them together, does that equal 9? Nope, of course it doesn't, right? So we know that's not going to be it. What's the next number we can multiply? So 1, next would be 2. Yep, 2 times 9 gives you 18. So now let's see if 2 plus 9, obviously 2 plus 9 is not going to give us 9, so we know that can't be the right one. So the next number in our list is going to be 3. Does 3 work? Yep. 3 times 6 gives us 18. So 3 plus 6, oh, there we go. That's the one that equals 9. Sorry, I don't know what is happening with my handwriting today. So 3 plus 6 are the magic number because they do multiply to get 18, but they also add to get 9. And they're both positive because a positive 3 times, oh, I don't know why I wrote 6. A positive 3 times a positive 6 gives you that positive 18. And a positive 3 plus a positive 6 adds to get 9. So that's why we know it's x plus 3 and x plus 6. You know, we have to throw a little wrinkle in there, and we're going to have to throw a negative in there because so far we've just done all positive numbers, which is a little bit more straightforward. So now let's try one that is a little bit less straightforward, which is going to be that, because we've got a negative thrown in there now. I'm going to go ahead and start off with my empty binomials because I know I'm going to have those eventually. And I'm going to factor the x to the second power. So that's going to be an x times x. So now I'm going to set up my table, and I'm going to ask myself, what can I multiply to get c, which in this case is 20, that I can also add that will give me b. And this time b isn't 12, it's a negative 12. So I've got to think of the numbers. Let's start with what will multiply to get 20. So I'm just going to start with 1 times 20. But I'm going to have to think a little bit more strategically because I need these numbers to add up to a negative number. So none of the numbers that are in this column are going to be positive. And here's why. Because anytime I multiply a positive times a positive, I'm always going to get a positive number, right? So, and a positive times a positive, or I'm sorry, yeah. And so those, you can't ever multiply a positive times a positive and get a negative number. So I know it's not going to be a positive 1 times a positive 20, right? Now at the same time, it's not going to be like a positive number times a negative number because a positive times a negative number is going to give me a negative, and I need them to multiply up to a positive 20. So what does that mean that I need to do? It means that all the numbers I'm looking for here are going to have to be a negative times a negative. And the reason for that is because the only way I can multiply, because I've got to get them to multiply together to be a plus 20. So that means it's got to be a negative times a negative. And they've got to add up to a negative number, okay? So the only way I can add them to be a negative but multiply to get a positive is if I'm doing a negative times a negative. Okay, so let's test this one out. So if I do, let's see if 1 and 20 do the trick. Well, -1 plus -20 does not give me -12. So I know those are not the two that are correct. And I just realized I'm going to change these to white, because I want my right answer to be that yellow. Sorry, guys. Matt, ADD, I got to have it to be the right color. All right, so -1 doesn't work. So now the next one I'm going to try is -2. So -2 times -10 gives me 20. So, and we need to add them to test. So -2 plus -10. Oops, there we go. There's my -12. So I know that those are the two that are correct. And because they're negative numbers, that means I'm going to need to put them as Alrighty, so now you guys try it yourselves. And so pause the video for a minute and take a look and see if you can give this one a whirl, and then unpause the video when you're ready to check. I'm going to assume you did that. So we are factoring this into two binomials. We know that because this is a quadratic trinomial where a is equal to 1. I'm going to factor the p to the second power, which means it's going to be a p and a p. And now I need to figure out what is going to multiply to get C, which is going to be 48, that will also add to get B, which is negative 14. So we're going to have to use our logical reasoning. This is definitely the hardest part, right? Is trying to figure out like what sign. So let's go ahead and just figure out what we can multiply to get 48, and then we'll figure out the signs, okay? So we could do 1 times 48, 2 times 24, 3 times 16, 4 times 12. 5 won't go into 48. If I use my calculator, 48 divided by 5 does not turn out to be a whole number. So I'm not going to include 5 here. 6 times 8 gives me 48. And if I do 48 divided by 7, it doesn't turn out to be a whole number either. So since the next number on the list that I would try would be an 8, and I already have an 8, I know that I'm finished finding the factors for 48. So now let's figure out what kind of sign they're going to have to be. So first of all, they have to multiply to get a positive 48. So that means that these are going to have to be the same sign. And the reason they're going to have to be the same sign is because either a negative times a negative gives me a positive, or a positive times a positive gives me a positive. So these numbers have to be the same sign. And then in order to get them to be a positive 48. But for them to be the same sign, but add to be a negative 48, that means I got to do a negative plus a negative. So that means that all these numbers we're going to try out have to be a negative, because they got to be negatives, so that a negative times a negative gives me a positive 48, but they add to give me a negative number. So now let's try adding them together and see what works. So negative 1 plus negative 48 definitely does not give me negative 14. Negative 2 plus negative 24 does not add together to get me negative 14. Negative 3 plus negative 16 does not add together to get me 14. Negative 4 plus negative 12 is getting closer. Still doesn't add up to negative 14. So that means it's got to be this one, right? So negative 6 plus negative 8. There we go. There's the magic pair that add up to negative 14. And because they're both negative, that means it'll be P minus 6 and P minus 8. All right, one more for you to try. I'm going to assume that you've paused the video, you've tried it yourself, and now you're ready to check yourself. So the first thing I'm going to do is start off with my binomials like I know I need to do. I'm going to factor that n to the second power and do an n times an n. And now I need to figure out what am I going to multiply to get negative 27, because that's C, that I'm going to add to get negative 6. So the first thing I need to think about is that in order to multiply and get a negative number, they're going to have to be a different sign. But let me go ahead and figure out what I can multiply to get 27, and then I'll come back to that idea in a second. So I know I can do 1 times 27. If I do 27 divided by 2, that does not turn out to be a whole number. 27 divided by 3 does, though. It's 3 times 9. 27, 4 doesn't go into 27, 5 doesn't, 6, 7, 8 do not. If you run through them, you'll see that none of those go. So these are the only factors of 27. So they have to be a different sign. So that means either it could be a negative 1 times a positive 27, negative 3 times a positive 9, Or it could be a positive 1 times a negative 27 and a positive 3 times a negative 9, right? Well, in order for them to add together to become a negative number, that means the bigger one, or the one you have more of, needs to be the negative number. So the only two I really even need to look at are these two right here, because it needs to add up to get a negative number. I think you probably already know, my at-home audience, 1 plus negative 27 does not give us a negative 6. However, a positive 3 plus a negative 9 does give us a negative 6. So that means that those are the magic numbers, positive 3 and negative 9. So this will be n plus 3 and n minus 9. I just realized that something else I should have mentioned to you is that it doesn't matter which of these numbers you put first. Like, the order doesn't matter. So I could have done n minus 9 and n plus 3. Either way, it means the same thing.